Hi folks, welcome to repair video number 4. On the bench is a 1977 Atari Breakout. Influenced by Atari's 1972 release Pong, Breakout was released in 1976 and became a worldwide success and was among the top 5 highest grossing video games of that year. Like Pong, Breakout is discrete logic, which means no microprocessor is involved. The logic chips are hardwired to do one job only. So what is the link between Atari Breakout and Apple computers? Follow the link in the video information below. Hi folks, we've got a new video and this is a Atari Breakout. Obviously quite historical that Steve Jobs and Steve Wozniak worked on this at Atari, who obviously later formed Apple. This is dated 1975, but I think they were making these through until 77, so I'm presuming this is a later board. As you can see, it's all logic, there's no CPU or anything like that, it's all hardwired, a bit like Pong. And as you can see, it's working. However, the owner says that when you play the game and you hit one of the bricks, it tends to take out other bricks which it hasn't hit. So as it takes one out, it will take another brick out on another row or column, which is a little bit odd. Now, I believe that these things have a slightly different way of wiring them up, where some of the buttons have to be actually present for it to actually work. So I'm going to have to make up a bit of a test harness to do this with a load of micro switches. So that's what I'm going to do at the moment, and I will see you shortly. So we got the Breakout wired up. I've done this, excuse me, I've done this array of switches and things. I put it onto the edge connector, got the video wired up, and as you can see, they're all running. However, the blocks aren't drawing properly at the top of the screen. I've done some initial testing, and based on the schematic, I've been testing some of the signals, and particularly around this chip here, which is a RAM chip. And there's something not quite working right around that. Now there's a number of signals. When it starts up, it loads that RAM chip with the brick pattern by using the horizontal and vertical counts, so it knows where to display them on the screen. And it initially draws the ones that you can see, but obviously it's not drawing them all the way across the screen. Obviously something isn't quite right with that. So I'm possibly looking at that at the moment. So here's the schematic for this RAM. As you can see, we've got these horizontal and vertical lines which come in. So depending on where they are, and you've got the read and write signal here, and you've got data coming in. So it's kind of clocking this data input here. So that clocks, and the read and write kind of, in this case write, would come on. It basically sets these addresses here by the horizontal and verticals. So it basically creates the brick pattern on the screen, which is obviously something that's not quite working right. So I've tested that we've got a digital output, and we have of some sort, and sorry, digital output, data output, and a data in. But I'm thinking that there's something not quite working internally to this chip. Now it says here that it's an 82S16, and on the board it's an 82S17 with a resistor stuck across the top of it from the data output to 5 volts, and it's basically the fact that they've used an open collector instead of a tri-state chip. So the open collector in this case needs a resistor to the 5 volts, basically to condition the signal right for the circuit. It's what we call a pull-up resistor. So I'm going to be having a look at this further. So back to the board again. While I've been probing around the chip, I haven't got previous video of it, but now it's doing something slightly different. So if I credit the game up, as you can see, it gets ready to play, resets the scores. When I press the serve button, the entire bricks disappear instantly, and they don't come back again, even when it's the end of the game. Which is a little bit odd. So it looks like something's dying on it. So as we can see, it's gone back to a track mode now. So if we credit up then for another game, it should fill the bricks up again, and it's not. So I think we're gonna I want to change that chip. So we put the new RAM chip in and switched it on, and as you can see, we've got all our blocks back. And if we credit it up and serve, you'll see they work properly. As the brick disappears, we don't get any kind of anomalies. However, there's always a however. As you can see, the score isn't working. No score. The ball speeds up properly. So it's making progress, but some further investigation, I think. I just wanted to highlight how good these Atari manuals are. They generally have a theory of operation, and as well as giving you the kind of signal flow of the entire game and how the game works, etc., they also go down into more detail on how the specific circuit works. So you can see here it refers to the clock generator, and it gives you the locations of the circuitry in relation to the schematics, in this case sheet 1 zones 7 and 8, and it gives you some information about certain signals and what they're doing. So as you can see, we go through these: picture rotation, a bit on the power supply there, got coin recognition, and for example, this was the one that I used for the brick display. It highlights about the RAM device at L3, which is the one I replaced, and it also describes this set brick signal, which restores the bricks back to normal again, and how that works with the horizontal and vertical counts. And if we go down to here, we've got this one which highlights the player score registers. So it talks about these chips here, and there's H6, J6 and K6, which are for the player 1 score. It says both registers are reset to zeros at the beginning of each play sequence, which that bit works. And then for the score to work, there's a pulse on this count 1 signal, and that obviously increments player 1 and count 2 increments player 2. So obviously we need to test this and see if this count 1 signal is actually working. So we'll go to the board now, and we'll put the oscilloscope on count 1, play the game and see what happens. Okay, so looking on the schematics, we can see we've got count 1 here, which goes to H6, J6 and K6, and it goes to pin 2. So I've set up the probe on this particular chip, so we've got it monitoring that pin, and we're going to credit it up and play the game and see what happens. So you won't be able to see the screen because of my setup, but basically I'm going to tell you when the ball hits a brick, and what we should do is we should get a pulse on the oscilloscope, because that's monitoring count 1 signal. So I'm going to serve now, and alright, off we go. So it's going to hit now, it's going to hit again, and as you can see, the signal is dead. Hit, hit, hit. So there's nothing. Now while it's flashing, what I'm going to do is I'm going to get a jumper, and I'm going to touch that pin 2 to simulate the count and see if the score goes up. And as you can see, as I touch the score, it changes. So we know that the count signal is dead, so we've got to find out where the count 1 is coming from. So the counts, these count signals comes from this circuitry here. So I think I'm going to work myself backwards. And check this gate here. So we'll check pins 9 and 10 on N7, which is an 7408, and we'll also be checking the output 8 there, regardless of what's happening on 9 and 10, because we could have signals coming in and it's just basically that the gate's dead. So we'll check those now on the oscilloscope. So I've worked my way back to this chip here. So I've tested that we've got 16H and 8H coming in, and there isn't that many other inputs really. We've got a few which are connected to 5 volts. I've checked this S clock signal here, going into pin 12 on, just bear with me. Should go kind of like that. So on N708. So everything after N708 is dead. But I've checked the input coming in on 13. We've got an S clock signal, but we've got nothing on this 74192 on pin 13. There's nothing coming out of it. Now we've got this start game signal coming in on pin 14, which is the, as you can see, CL. That's that clear. That clears the chip basically. So we'll test that now, and I'll show you the signal on the oscilloscope. Now there's times when you're detecting a signal and it happens so quick that sometimes you just won't even see it. So what we're going to do is, if you can just see this, this oscilloscope's got different modes. So what I'm going to do is, instead of having it on auto, I'm going to move it across, and it's now set on single. So it's looking for just a single change from either high to low or low to high. So I've got my probe connected up. So I'm pressing the coin button now, and just bear with me. Not quite doing what I want it to do at the moment. Right, okay, so we press credit, and when we press start, we should get a signal. So what it's doing is it's sending a signal to reset the score, and as you can see, we have captured the signal. It goes from low to high, so we know that that signal is working. So the common factor in this fault is this 74192. Now I can't remember what that is off my head, so I'm going to look it up. So I've looked it up, and it's you can hardly see the writing on the chip. It seems to have disappeared. It's probably got hot, that's probably why it's faulty. It's a decade binary counter. So I'm going to try piggybacking another one on it and seeing if it jumps to life after then. It might not, but it's looking most likely that this is the culprit. So we'll piggyback it and see what happens. Just going back to this again, I overlooked something here where the actual pulse at this gate comes from pin 11, which says LD, which is the load, and it comes down here to this 9602, which is a flip-flop. Now I've just checked on the not Q output on pin 9, and that's dead, but we're getting the signal from the brick hit, which is obviously the pulse for it, to make it so we get the count 1 or count 2 later on. So on pins 11 and 12 we've got one which is provided a 5 volts, and then you can see the little round circle on it which inverts that. And then we've got the briquette coming in. Now the briquette signal is present, but there's nothing happening on the output at all. So it looks like that's the culprit rather than the 192. So I'll do a few further checks on there, and we'll be looking at probably replacing that. So just looking at what the 9602 is, it seems that it's a dual retriggerable, resettable, monostable multi-vibrator chip, which basically just gives like a one-shot burst when it's triggered. I've just connected a jumper lead to the 0 volt line and just pulsed that pin 9 trace there, which goes up to the load input on the 192, and it scores up. So we can see that we've got the briquette hit signal coming in, that works, and it's dead after that. So it's definitely this 9602 which is faulty. So I'm gonna have to try and have a look. I'm just seeing if there's an equivalent chip, a standard 74 series logic chip to go in there. I don't know if there is yet, so I'm gonna have to do a little bit of research. So I've replaced the 9602. Let's see if we've fixed it. So let's credit the old girl up. Off we go. Yeah. So that's working as it should. We have the points back. I think my pot's still a little bit dicky. Yeah.